Hello guys. Well, in this video we are going to go over another dynamic routing protocol, and this one is not as old as RIP and it's widely used. A lot of companies use this dynamic routing protocol, which is OSPF, and stands for Open Shortest Path First, and it's a link state routing protocol. Remember that this is a link state. RIP is a distance vector routing protocol. This one is a link state routing protocol that is commonly used in large enterprise networks with L3 switches, routers, and firewalls from multiple vendors. It can quickly detect link failures and converges network traffic without networking loops, and it also has features to control which routes are propagated, allowing for smaller routing tables, and provides better load balancing on external links when compared to other routing protocols such as RIP. So that's what we're going to be doing. So to configure OSPF, right, we're going to go to Network OSPF. We need to specify the router ID. This one needs to be a unique ID to identify your router in the network, and typically in the format of x.x.x and the areas. So we need to also configure an area. We are just going to use area 0 and the areas that the router is part of. For each area, define the area ID, type, and authentication method. Networks, over here we're going to specify the networks that OSPF is enabled and the area that they belong to. And we got to do the interfaces, of course, and if you want to do more advanced options like to inject a default route, passive interfaces, and redistribute. And redistribution can be enabled by protocol, and the metric for each protocol can be configured. All right, so let's go ahead and do that. Let's go ahead and go to the topology. First of all, we're going to do some cleanup first. So this one is to log into firewall 1. Cleanup meaning that we need to go ahead and delete RIP version 1, right? We are going to just delete all of this and delete this too. Okay, hit apply to save it, making sure it's gone. It is. Go ahead and go to firewall 2, and let's just go ahead and save this password so we don't have to type it every single time, right? So over here, let's go ahead and delete all of this and delete these two interfaces. Okay, apply it, and let's go ahead and go to the last one, which is 3, firewall 3. Let's go ahead and save it too, and let's go ahead and delete this too. We don't need it, and we don't need these interfaces to enable. Let's go ahead and press OK and apply. Awesome. Let's go ahead and go to OSPF. So for this one, I want to start with firewall 1. So go to firewall 1. The router ID for this one, let's call it 1.1.1. The area, we're going to create a new area, area 0. We are not going to have any authentication, no plain text, no anything. Press OK in here. And then we need to add the networks that we want to add. So we want to add to area 0. We want to add 192.16.1.0/24 beans. And then the next one that we would like to add is to area 0 as well. We want to add it to 172.16.1.0/24, right? So just like we did with RIP, we added those and we added it to the same area. Let's go ahead and create interfaces, or add interfaces in here. So the interface that we want to add in here, we want to add port 4 name. I just call it MPLS. The IP 172.16.1.1/24. Oops, what did I say? Oh, just want it like this. Cool. So the MPLS network is actually 254. Cost, everything, we are going to leave the same. Passive is disabled, and passive for OSPF is the same one. Let's go ahead and say LAN. And for this LAN over here, we are going to use 192. Let's just call it VLAN underscore 192. 192.168.1.254. Okay. And we're not going to do any summarization, metric type, everything. You can do a lot more with, with OSPF. That's why a lot of people use it. And let's go ahead and apply it. Now let's go ahead and go to the network, and we shouldn't see anything in here because we haven't configured any other firewalls. So it doesn't know anything about, any other neighbors. And let's go ahead and configure a new neighbor. So firewall 2. So we go to OSPF. We are going to this say router 1.1. No, this is 2.2.2.2. The area is going to be area 0, and they need to be in the same area. Let's go ahead and configure some networks in here to area 0. 192.168.2.0/24. Add it. The other network is 172.16.1.0/24. And for the interface is going to be called, I'm going to call it MPLS. Interface that we want to add is the MPLS port 1. IP address 172.16.1.2. Okay. Apply it. Now we should be able to see a neighbor in here and some routes. Nothing yet. Everything is static and connected. Let's go ahead and give it a minute. And there we go. After a couple seconds, we can see that we have a network. 192.168.2.0 via 172.16.1.2. So we learned from firewall 1, we learned that we can get to 192.168.2.0 via 172.16.1.2, which is firewall 2. Okay, we can see it over here. So now let's go ahead and configure firewall 3 with OSPF. So firewall 1 and then firewall 2 can learn about firewall 3, because if we go to firewall 2, we are going to see that we have a network that we can get to. It's not showing here. .192.168.2.0. Did we misconfigure that 2.0? Let's go ahead and go to networks and OSPF. So we say 192. Oh, there's a typo here. 192.168. There we go. That's why we were not able to see it over here in firewall 1. So eventually it's going to show it here. Let me see 172.16. So the other ones are correct. Let's go ahead and just apply that for firewall 1. Let's go ahead and go to firewall 3. Router ID 3.3.3.3 because it's firewall 3. The area that we're going to configure is just area ID of 0. We are going to create networks in here, and we're going to add it to area 0, 192.168.3.0/24. And then we need to create another one, which is the one that's going to form the neighbor relationship, 172.16.1.3 or that 1.0/24. All right, Yep, that looks correct. And now we go ahead and create that interface. Of course, we are going to call this MPLS. The interface that we're going to be using is port MPLS port 1. IP is going to be .3, 172.16.1.3. Press OK over here. Press apply. Now let's go ahead and go to firewall 2. We can see that we can get to now. We learned 192.168.1.0 via MPLS port 1. So that is great. And let's go to firewall 3. And we can go to network. Expand this bad boy. Now we can see over here we have learned 2. And we can see that we have 192.168.1.0, right? We can get to it via 172.16.1.254, which is firewall 1. And to get to 192.168.2.0/24, we can get it to, we need to go to 172.16.1.2. So this one is firewall 2. That's the way that we can get there. And if you can see the distance over here, if you remember on the previous video, the distance for RIP was 120. For OSPF is 110. Something that you need to remember. So if we have two, if you configure RIP on your network and also configure OSPF, the routing table that is going to be injected or added to the routing table is going to be OSPF, because the distance of OSPF is lower than RIP. Okay, something to remember. And you can see that directly connected, for the directly connected interfaces, the distance is 0. So if it is directly connected and it knows how to get to it, it is going to use this route to get to it. So that's how the distance works. Okay, so now we can also do, I can show you guys, let me see if we can see everything over here. Network, making sure that I can see everything also from firewall 1, which we should. We have 2 routes, OSPF and OSPF, and you can see that the distance for static is 10. So if you have a static and you have an OSPF with the same destination and same with the same network, right? And with this going to the same network, the one that's going to be added into the routing table is going to be the static route, because it has a lower distance. Okay, something to remember, that the lower the distance, the better it is in routing. And okay, so over here, let's go ahead and run some commands that you can use, so you can see basically, so you can take a look at OSPF. So if we do get router info, routing table, or you can see everything in here. You can see the static routes, right? This one looks like a Cisco router or a Cisco layer 2 switch. We can see S is for static, and this one, when it has the S, means static, and when it has the asterisk, means that is the candidate, is a default, so it's a default route. And C means is directly connected, or is C in here? Here we go, connected. And O is OSPF, right? So also you can do more. If we go to get router info OSPF interface, this one in here, with this one just looks, you know, like a Cisco router. So here you can see 192 is up, line protocol is up. You can see the IP that it's using. You can see the area where it's being advertised. You can see the router ID that is being used and all of that good stuff. And you can see that port 4 is up as well. And it has the, you know, internet. This is the internet address that it's using, the area, and the router ID. State DR, priority 1. Looking good. You can see that we have a backup designated router, 2.2.2.2, meaning that the firewall 2 is a backup designated router for this area. All right. And you can also get router OSPF, which is the last command that I have for you. And this one just gives you, you know, a lot more information here. It gives you the distance, the inter area, the intra area distance, the database overflow is being disabled over here. You can see the router ID for this firewall is 1.1.1.1. We can see the networks that we are advertising and the interface that we are using to advertise, and you know, a lot of good information. And guys, this is it for this video. Hopefully you guys enjoyed this video on OSPF and on the previous video on RIP, and I will see you in the next one. Bye bye.